Hi, my name is Yvette from T22 Agri Science. Before we start, I have stated the context here for a better understanding and clearer view for all of you. So to begin with our presentation here, please allow me to explain brief introduction. So, Malaysia is currently facing rising food prices due to global supply chain disruptions, increasing fertilizer costs, and heavy reliance on imported food. While overall food supply remains stable, affordability has become a major concern, especially with expected price increases in vegetables. Inflation has further driven up production and distribution costs, affecting households, small businesses, and local farmers in rural places. As families spend more on food, businesses struggle to maintain their profits, and farmers face reduced returns. The pressure on the economy continues to grow. This study aims to analyze regional and temporal data from the three states that we have selected, which is from Johor, Kelantan, and Pahang within the year of 2017 and 2022 to identify trends and differences across states and to examine how these patterns relate to food price changes, supply stability, and potential strategies to improve affordability while supporting local production.
Hi, I'm Lindsay Priscilla. I'll be presenting vegetable production data from 2017 to 2022 for three states, Kelantan, Johor, and Pahang. First, let's look at Kelantan. We can see that the production show a steady increase starting from about 116,000 and rising to nearly 138,000 metric ton in 2022. Next is Johor. Johor, the production also increased, but what interesting is the share price after 2020 reaching over 245,000 metric ton by 2022. Last, Pahang. This state clearly recorded the highest production throughout the years, with a peak of over 455,000 metric ton in in 2022.
Okay, so hi everyone, I'm Yvette, and now we will be moving on to frequency and cumulative frequency. I have already stated the steps here and there are 7 of them. So first of all, we need to find the range. The formula for finding range is when you need to use the biggest value minus the smallest value. So for Johor, I've already stated the maximum and minimum value. Then the range should be 46870.6 and Kelantan 21002.9 and Pahang 119706.4. After that, we need to find the number of classes and class width. By using this Burgess rule, k equals to 1 plus 3.3 log n, where n is the total number of observations in the dataset. In this case, there are 6 total number of observations in the dataset. So, the value should be substituted into the formula and the answer is approximately 4 classes. For class width, by using the formula of range over k or number of classes, for Johor we will have approximately 11718, Kelantan approximately 5251, and for Pahang 29927. Then after that, we need to set the class intervals and boundaries. I have already stated for each state here, and then we need to distribute the frequency. For Johor, the frequencies are 2102, Kelantan 1221, and Pahang 2211. And lastly, for frequency, We will need to add all of the frequencies progressively to find the cumulative frequency. For Johor, we have 2335, Kelantan 1356, and Pahang 2456. After that, we can construct a table for each state, which I have already placed and pasted there in this page. Thank you.
Based on the frequency distribution and cumulative frequency tables for Johor, Kelantan, and Pahang, 2017 to 2022, Pahang shows the highest vegetable production values with data concentrated in higher class intervals. This indicates Pahang consistently produces more vegetables compared to the other states. Johor has moderate production values with frequencies spread across middle intervals showing stable but not extreme changes. Kelantan records the lowest production values with most data grouped in lower class intervals. From the cumulative frequency, we can see how production values gradually increases across the classes, helping compare overall distribution patterns between the states. Overall, the comparison shows clear differences in production levels, suggesting regional factors such as land use, climate, or resources may influence vegetable output. The data was analyzed using several statistical tools to identify patterns and compare vegetable production across Johor, Kelantan, and Pahang. A histogram was used to display the distribution of production values, while the frequency polygon helped show the overall shape of the data trend. The OGIF cumulative frequency curve was used to observe how the cumulative frequency increases across class intervals. Measures of spread were calculated using the standard deviation, which shows how far the data values vary from the mean. The quartiles, quartile 1, median, quartile 3, were used to divide the data into 4 equal parts, and the interquartile range was calculated to measure the spread of the middle 50% of the data. Finally, a side-by-side box and whisker plot was used to visually compare the distribution, spread, and central tendency between the states, making it easier to identify differences in vegetable production levels. This is the mean, standard deviation, quartile 1, quartile 2, quartile 3, and interquartile range. The mean is calculated by adding all the data values together and then dividing by the number of values. The sample standard deviation is found by subtracting the mean from each data value, squaring the result, adding all these squares together, dividing by 1 less than the number of values, and then taking the square root. The quartiles show the position of values that divide the data into 4 equal parts. The first quartile, quartile 1, is at 1/4 of the way through the data plus 1. The second quartile, quartile 2, which is also the median, is at the halfway point of the data plus 1. And the third quartile, quartile 3, is at the 3/4 of the way through the data plus 1. The interquartile range is found by subtracting quartile 1 from quartile 3.
Interpretation and discussion. Key patterns and trend. Johor shows moderated variation with most data concentrated in the lower and highest class intervals. Kelantan display a more balanced distribution with values spread eventually across intervals. Pahang has consistently higher value overall, indicating stronger output level compared to the other states. Symmetry and skewness. Johor, slightly irregular distribution, gaps in middle class. Kelantan, approximately symmetrical distribution. Pahang, slightly positive skew, more lower to mid frequencies, fewer high values. Comparison between states. Pahang is the highest overall values, suggesting stronger performance. Kelantan shows stable but lower values. Johor shows fluctuation indicating consistency. Overall, Pahang, Johor, Kelantan in terms of value range. Real-world factors. Difference may be due agricultural capacity and land availability, weather or climate condition, level of infrastructure and investment. Linked to food price, higher production may help stabilize food price. Lower or inconsistent product may lead to price fluctuation. Conclusion insight. The variation between states shows that regional production difference direct affect food supply and pricing stability in Malaysia. That's it.
First, I arrange the data in Microsoft Excel by placing each state in a separate column. For example, I use Johor, Pahang, and Kelantan as the column headings and entered all the corresponding values under each state. This arrangement is important because Excel reads each column as a separate data category. By organizing the data in columns, it becomes easier to compare the distribution between the three states. Next, I highlighted the entire data range, including the headings and all the values. After that, I went to the Insert tab and selected Insert Statistic Chart, then choose Box and Whiskers, which automatically generated the box plot. The box plot is useful because it helps visualize the distribution of data, including the median, quartile, and the spread of values for each state. Based on the statistical analysis of food prices in Johor, Pahang, and Kelantan, clear differences in price stability can be observed. Kelantan has the most stable food prices with a small range of 21,003, 137,913 minus 116,910, and a narrow interquartile spread indicating that prices are closely clustered around the median. Johor shows moderate stability with a range of 46,484, 245,330 minus 198,846, suggesting some variation but still relatively consistent prices. In contrast, Pahang has the least stable food prices, with the largest range of 119,573, 455,641 minus 335,944, and a wider interquartile range indicating significant fluctuations in prices over time. Therefore, the research aim is achieved. Food prices in Malaysia are not equally stable across states, with Kelantan being the most stable, Johor moderately stable, and Pahang the least stable based on variability measures such as range and spread. These findings have important implications. Communities in states like Pahang may face greater financial uncertainty due to fluctuating food prices. This suggests that policymakers should consider improving supply chain efficiency, strengthening price monitoring system, and implementing targeted subsidies or controls to reduce volatility. Better infrastructure and distribution systems could help ensure more consistent food prices and improve overall economic stability for households.